Hello all, I am Dr. Prabhas Sanjanbal. In today's class, we will discuss about the closure properties of CFL and DCFL. CFL means context-free language, DCFL means deterministic context-free language. So, in the previous class, we have also discussed about some closure properties of CFL and DCFL with the help of examples. Now, we'll discuss the total overall closure properties of CFL and DCFL. Means which properties is closed under CFL and closed under DCFL operation. So first operation or first property is union. First property is union. Union is closed under CFL. Union is closed under CFL. Union operation is closed under context-free language, and union operation is closed under DCFL. Closed under DCFL operation means it's not closed under or need not be closed under. We can say union operation need not be closed under DCFL operation or deterministic context-free language. So next operation is concatenation operation. Concatenation operation is closed under CFL operation. Is closed under CFL operation, and concatenation operation need not be closed under DCFL operation. Means concatenation operation is not closed under deterministic context-free language. Then clean closure. Clean closure operation, or it is also called a star operation. Clean closure operation is closed under CFL, means context-free language, but it's not closed under DCFL. But is not closed under DCFL operation, means deterministic context-free language. Positive closure. Positive closure is closed under CFL operation and is not closed under DCFL operation. Then subset. Subset is not closed under CFL operation, and subset is not closed under also DCFL operation. So subset is not closed under CFL and as well as DCFL operation, DCFL language. Then intersection. The intersection properties of CFL, the intersection operation is not closed under CFL operation, and the intersection operation is not closed under DCFL operation. DCFL language means deterministic context-free language. Then the next operation, union with regular. Union with regular means means context-free language union with regular. So context-free union with regular means context-free language union regular. Union with regular operation is closed under context-free language and it's not closed under DCFL language. Then eighth operation, intersection with regular. Intersection with regular operation is closed under intersection with regular means CFL intersection regular. CFL intersection regular. Intersection with regular operation is closed under CFL language and is also closed under DCFL language, means deterministic context-free language. Then complement. Complement operation is not closed under CFL operation. CFL language. CFL language, and the complement operation is closed under DCFL language. Then difference. Difference is not closed under CFL language, and the difference operation is not closed under DCFL language. Then next is L minus regular. L minus regular means the difference, that is called difference with regular. Means suppose context-free language is difference with regular, that means like this. Or we can write difference with regular. Difference with regular. So difference with regular is closed under context-free language and is also closed under the CFL language. Then reverse. Then the reverse operation is closed under CFL language and is not closed under the CFL language. Then next one is substitution operation. Substitution operation is closed under CFL language and is not closed under the CFL language. Then homomorphism. Homomorphism is closed under CFL language and homomorphism operation is not closed under the CFL language. Then inverse homomorphism. Inverse homomorphism is closed under CFL language and is also closed under the CFL language. Then quotient operation. Quotient operation is not closed under CFL language and quotient operation is not closed under the CFL language. Then 17. Quotient with regular. Quotient with regular is closed under CFL language and is also closed under the CFL language. Next, the last closure properties, or we can say the last operation. The last operation is the init operation, or we can say initial operation. We have already discussed about the initial operation in the regular classes, means in the regular language classes, means closure properties of regular language. What is the meaning of init? What is the meaning of init? Substitution, homomorphism, inverse homomorphism, quotient with the regular. Everything we have already discussed about the closure properties of regular language classes. The last one is init operation. The init operation is closed under CFL. Is closed under CFL and is closed under the CFL language. So these are the complete chart of closure properties of CFL and the CFL language. Okay. Now we'll see some examples that are related to the closure properties of regular and also context-free languages. Okay. So before coming to this question, so first try to understand what is the meaning of closure properties of context-free language and closure properties of regular language. Okay. So try to understand the meaning of the question. Let L1 and L2. Let L1 and L2 are two context-free languages. Let L1 and L2 are two context-free languages, and L3 and L4 are two regular languages. Here L1 and L2 are two context-free language, and L3 and L4 are two regular languages. So which of the following is always context-free language? Okay. Now we have to find which one is context-free language or which one is not context-free language. Okay. So see, here L1 and L2 are two context-free language. So L1 is CFL and L2 is CFL. Since L1 is CFL and L2 is CFL, so both union properties also CFL. Both properties also CFL. So finally L1 union L2 is CFL. Now we'll see. Here L2 is regular, L3 is regular, and L4 is regular, and both union is also regular. Now we'll see. This part is completely CFL. This part is completely regular. CFL intersection regular. CFL intersection regular. So intersection with regular is always context-free language. It is always context-free language. So A will be context-free language. In this way, we can find out this expression. Okay, now we'll see the next question. Here L1 is context-free language. The closure properties, the clean closure. Star means here clean closure. The clean closure of context-free language CFL. The clean closure of CFL is always CFL. So L1 star is always CFL, and L3 is here regular. Here intersection with regular. Intersection with regular is means CFL intersection regular is always CFL. So this part is total is CFL. Now we'll take the union. Complement L4 is regular. Here L4 is regular. Summation star minus L4. That means it is called complement operation. This is called complement operation. So complement of regular language is always regular. So this part is regular. So L1 intersection regular. L2 intersection regular. L2 means context-free language. Context-free language intersection regular is always context-free language. So CFL union CFL is always CFL. So B is CFL. Okay, now we'll see one more question. This is a little bit complicated here, but easy. L3 is regular. Summation star minus L3. L3 is regular. Summation star minus L3. Summation star minus L3 means complement. Complement of regular is always regular. So this one means regular. And clean closure of regular. Then clean closure of regular. Clean closure of regular is always regular. So entire this part is regular. And L1 is context free. Here L1 is context free. Reverse L1R. L1R means this is called a reverse of L1. This is called what? Reverse of L1. This is called a reverse of L1. Okay. So reverse operation, reverse of context-free language. Reverse of context-free language is always CFL. This part is CFL, and this part is regular. CFL intersection regular. CFL intersection regular is always regular, means this part is always regular, then intersection. So now we'll find L4. L4 is regular. Reverse of regular language. L4 is regular. L4R means reverse of L4. Reverse of L4. So reverse of regular language is always regular. So this part is completely regular. Now we'll find. This is the complement of L3. Here L3 is regular. Here L3 is regular. Complement of regular language. Complement of regular language is always regular. That means this part is also regular. And regular of reverse. Reverse of regular language is always regular. So this part is regular. So regular intersection regular is always regular. Reverse intersection, this is called regular. So this part is entire part is regular. Sorry, this part is actually not regular. This part is context-free language. This part means this part is context-free language actually. How? See. Here L1 is CFL. Reverse of L1 is CFL. CFL intersection. L3 is regular, its complement is regular, it means summation star minus L3 is regular, and regular star, regular clean closure of regular is regular. So CFL intersection regular is always CFL. So CFL intersection regular is nothing but CFL. So C is, option C is CFL language. Okay. Now we'll see the next question. D. Here L1 star. L1 is CFL. Clean closure of L1. Clean closure of L1 means clean closure of CFL. Clean closure of CFL means this is CFL. Then L3. Here L3 is regular. Positive closure of regular is regular. Positive closure of regular is regular. CFL dot means concatenation of CFL and R. Concatenation operation is always CFL. Sorry, concatenation with regular. Concatenation with regular is always CFL. Is always CFL. Then we'll see L2 reverse. Here L2 reverse. Here L2 reverse. Here L2 is CFL. CFL reverse is CFL reverse is CFL. Then intersection. L4 is regular and its complement. Regular complement is regular and reverse of regular is regular. So CFL intersection regular. CFL intersection regular is CFL. CFL intersection CFL. CFL intersection CFL. CFL intersection CFL need not be CFL. CFL intersection CFL need not be CFL. So this is not CFL. This is not CFL. Means D option is not CFL. Okay. So now we'll see the next question. Here L1. Here L1 is CFL. L3 is regular. So CFL concatenation of CFL and regular is CFL. And reverse of CFL is CFL intersection. Here L2 is CFL. L4 is regular. Concatenation of CFL and regular is CFL. Clean closure of CFL. Clean closure of CFL is CFL. So CFL intersection CFL. CFL intersection CFL is not CFL. Not CFL. So this part is not CFL. Okay. So this part is not CFL because intersection operation is not closed under CFL operation. Okay, so this type of questions may come based on the closure properties of regular language and the closure properties of CFL and DCFL languages. Okay, so this is the end of closure properties of CFL and DCFL languages. In the next class, we'll read about the pumping lemma of context-free language. Okay, thanks for watching.